Graphing rational functions. Vocabulary. Hyperbola. The shape created by graphing a rational function. Asymptote. A line. A graph approaches but never crosses. Rational function. A rational function in the form of f of x equals polynomial over polynomial. Okay, rational functions. Graphs create a hyperbola. Center, asymptotes, and branches. So, the shape is a hyperbola. This is our vertical asymptote, and this is our horizontal asymptote, and these are our branches. Okay, graphing form number 1. When an equation or a rational function is in the form of y equals a over x minus h plus k, your center is h and k. Remember that h is the opposite sign. So our vertical and horizontal asymptotes go through the center. So our vertical asymptote is x equals h, and our horizontal asymptote is y equals k. After, we pick numbers for x, find y, and graph the branches. Example, graph y equals 2 over x minus 1. Okay, so our h is 1, and we do not have a number that's being added or subtracted, so our k would be 0. So our center is 1, 0. So my vertical asymptote is x equals 1. So I'm going to represent this by a dashed line. My horizontal asymptote is y equals 0. And I'm going to represent this with a horizontal line that is dashed. So my domain is all real numbers except for x cannot equal 1. Because if 1 is placed in with x, then this would be 0 on the bottom, and that does not work. So my domain is everything on my graph except for my vertical asymptote. My range is all real numbers except for y cannot equal 0. So again, all real numbers except for y equals 0, or my asymptote. Okay, so we need to create an XY chart. So now I need to pick values for x. I like to pick values on either side of my vertical asymptote. So in this case, I'm going to pick 0 and 2. Okay, now I'm going to substitute 0 into my equation and solve to find y. So when I substitute 0 into this equation, I have 2 over 0 minus 1, which equals 2 over negative 1, which is negative 2. So this point is going to be at 0, negative 2. So now I can draw my branches for this side. So my branch is going to approach my vertical asymptote and my horizontal asymptote, but never cross. Okay, now let's input 2. So 2 over 2 minus 1, which is 2 over 1, which is 2. So this point is at 0, negative 2. Well, that was my other sign. Oh, 2, 2. That was over here. I'm sorry, I graphed this one first. Okay, so this one is at 0, negative 2. Sorry, 0, negative 2. So again, I'm going to graph my branches. you will know that you have a correct graph if they are on either side of your asymptotes. They will never be next to each other. Okay, let's try this again. So now we're going to graph y equals -1 over x plus 3 minus 2. So my center is going to be -3, remember the opposite sign of h, and -2. Okay, so my vertical asymptote is x equals -3. So x equals -3. My horizontal asymptote is y equals -2. Y equals -2. So my domain is all real numbers except for x cannot equal -3. So all real numbers except for x cannot equal -3. And my range is all real numbers except for y cannot equal -2. Okay, so now I need to create my XY table and graph my points and draw my branches. So I'm going to look at my vertical asymptote. I want to pick a number on either side. So I'm going to go with -4 and 2. So when I input -4, I get -1 over -4 plus 3 minus 2. So I get -1 over -1 minus 2, or 1 minus 2, which is -1. So -4, -1. So again, my branches are going to approach my vertical asymptote and my horizontal asymptote, but never cross, like so. Okay, now let's input -2. So -1 over -2 plus 3 minus 2. So I'll have -1 over 1 minus 2, or -1 minus 2. So that is going to be -3. So my point is going to be at -2, -3. So my branches, again, are going to approach my horizontal asymptote and my vertical asymptote, but never cross. Graphing form number 2. When we have it in the form of y equals ax plus b over cx plus d, we're going to use division to get an equation into proper form. Find the center, draw the asymptotes, pick numbers for x and y, and graph the branches. Okay, so I'm going to use synthetic division to graph this hyperbola. So in synthetic division, I'm going to place my coefficients inside my synthetic division box, so 2 and 1. Then I have to set my divisor equal to 0, so x plus 2 equals 0. So x equals -2, so that's going to go on the outside. Then I need to bring down my 2. So -2 times 2 is -4. 1 plus -4 is -3. So remember that we use 1 less degree. So this is already to the first. So this is going to just be 2. And -3 is my remainder, which we put our remainder over our divisor. So this will be 2 plus -3 over x plus 2. Now I'm going to rewrite this so it looks more like my form. So y equals -3 over x plus 2 plus 2. Now I can find my center, -2 and 2. So now that I know my center, I can find my vertical asymptote, x equals -2. X equals -2. Then I can find my horizontal asymptote, y equals 2. Y equals 2. So my domain is all real numbers except for x cannot equal -2. And my range is all real numbers except for y cannot equal 2. Now let's create our XY table and substitute our values in. So I need to pick 2 numbers. So I like picking numbers that are on either side of my vertical asymptote. So I'm going to pick -3 and -1. So I'm going to substitute -3 into my equation and solve. So -3 over -3 plus 2 plus 2 equals negative 3 over negative 1 plus 2, which is 3 plus 2, which is 5. So my point is going to be at negative 3, 5. Negative 3, 5. So my branches are going to approach my vertical asymptote and my horizontal asymptote, but never cross. This can go on for infinity. So now I need to input my other value, negative 1. So negative 3 over negative 1 plus 2 plus 2. So negative 3 over 1 plus 2, which is negative 3 plus 2, which is negative 1. So my point is at negative 1, negative 1. Okay, so now here my branches are going to approach my horizontal and my vertical asymptotes, but never cross. They just infinitely get closer and closer and closer. Okay, let's try another one. Y equals negative x minus 1 over x minus 3. Okay, I'm going to use synthetic division, so I need to place my coefficients inside my synthetic division box. So negative 1 and negative 1. Then I need to set my divisor equal to 0 and solve, so x equals 3, and this goes on the outside. Now I'm going to bring down my first coefficient, negative 1. 3 times negative 1 is negative 3. Negative 1 plus negative 3 is negative 4. So remember, we do one less degree than the highest degree in our dividend. So I'm going to have just 1 here, and then negative 4 is going to be my remainder, so I'm going to set that over my divisor. So negative 1 plus negative 4 over x minus 3. Then I'm going to rewrite this so it's in a form which is better for graphing. So y equals negative 4 over x minus 3 minus 1. So now I can find my center, 3, negative 1. So my vertical asymptote is x equals 3. X equals 3. My horizontal asymptote is y equals negative 1. So this means that my domain is all real numbers except for x cannot equal 3. And my range is all real numbers except for y cannot equal negative 1. So now I'm going to create an XY table to find my values. I want to pick two numbers that are on either side of my vertical asymptote, so 2 and 4. So when I substitute 2 into my equation, negative 4 over 2 minus 3 minus 1 equals negative 4 over negative 1 minus 1. So 4 minus 1, which is 3. So my point is going to be at 2, 3. So 2, 3. So now I can draw my branches. Remember that your branches are going to infinitely approach your asymptotes but never cross. Okay, let's substitute 4 into our formula. So negative 4 over 4 minus 3 minus 1 equals negative 4 over 1 minus 1. So negative 4 minus 1, which is negative 5. So my point is at 4, negative 5. 4, negative 5. So my branches are going to infinitely approach my asymptotes but never cross.